Hey everybody, welcome to Pre-Cal. In Algebra 2, you studied a lot of different types of functions, and so to me it seems best to start with 2-3 properties of functions. Also because Section 1.1 in Calculus is also about functions. And so I want to make sure you have a good background on it. We have several objectives. One is to determine even and odd functions from a graph or equation, to use a graph to determine where a function is increasing, decreasing, or constant, use a graph to locate local maxima and minima, which are plurals of maximums and minimums, and absolute maximum and minimum. We also want to use a graphing utility, namely the calculator, to approximate the local max and min and determine where a function is increasing or decreasing and find the average rate of change. Again, in calculus, you need to know a lot about the average rate of change. Okay, so why we're studying this is to obtain the graph of y equal f of x. It's often helpful to know certain properties that the function has and the impact of those properties on the way the graph will look. So, for example, a function is even if for every number in its domain, the number opposite sign of x is also in the domain, and f of the opposite sign of x equal f of x. This means that when you substitute the opposite of x for x, you end up with the original equation after simplifying. So that's what even is. A function is odd if for every number in its domain, the number opposite of x is also in the domain, and the f of the opposite of x equal negative of f of x. This means when you substitute the opposite of x for x, you end up with a negative of the original function after simplifying. So just one quick note. We're going to go through all the theorems and definitions and stuff first, and then we'll get to problems. Okay, number 3, a function is even if and only if it's symmetric with respect to the y-axis. It's odd if it's symmetric to the origin. So those are important. I tried to bold most of the most important things, but those are important. So then it says try to find out to see if these functions are even or odd. Okay, so if we just have x, then that graph would look like that, because that's y equal x. And so that's not symmetric to the y-axis. It is symmetric to the origin. So that's odd. This one is y equal x squared, and that is symmetric to the y-axis. This one is y equal x cubed, and that would be odd because it's symmetric to the origin. And let's see, absolute value of x is the v. So that's symmetric to the y-axis. So that's even. And then 1 over x, it's like this and like this, and that's odd. So you may want to write these down for examples. This is just covering the high level of it without doing any transformations left or right, or up or down, or any dilations or compressions or stretches. So what you'll notice is, like, if the x squared one went down or up, it would still be even. But if it went left or right, it would not be even anymore. So you can't just say just because it has a 2 there makes it even. So it depends on all the details of the graph. So notice that if it's an even exponent, it can't be odd for sure. It includes functions that don't go through the origin, but the graphs must be symmetric. So as I said, if it shifts up or down, but it's still symmetric to the y-axis, then it's even. And likewise, if it's odd, it for sure can't be even. And it's not just functions with odd exponents, but it could be anything symmetric to the origin, like it's rotated 180 degrees. So you cannot have y equal x cubed plus 5 as odd. It's neither. So the original one would have gone through the origin, and if we shift up 5, then it's going to look like that. And so that's why it's neither. So it's increasing if basically when you're looking from left to right that the y values are also from left to right. You know, the left side's smaller than the right side. So this is basically saying left to right, and actually I should say down to up. Okay, and then it's decreasing if you're looking left to right, but it's going from up to down. So these are the formal definitions of it with the less than signs and greater than signs. But in general, like if you have something like let me just say like that. So from here over would be considered increasing. So I'm putting my I, or increasing. Because if you're looking left to right, it's going from down to up. And this side would be considered decreasing, because if you're looking left to right, it's going up to down. So that's what I meant by that. It's constant if the values are equal. In other words, it's a flat line. And then we get into specifics about a local maximum and local minimum. That just means within a certain interval. And same thing for the local minimum. And again, you may want to pay attention to the inequality signs. So then let f denote a function on some interval I if there's a number u in I for which f of x is less than or equal to f of u for all x, then f of u is the absolute maximum of f on that interval. And we say the absolute maximum of f occurs at u. And if there's a number v, then if f of x is greater than or equal to f of v, then it's the absolute minimum. We'll see examples of this in a moment. Then there's also the extreme value theorem. If f is a continuous function whose domain is a closed interval ab, then it has both an absolute maximum and minimum on that interval. Now, if these are all very, very technical. If a and b with a not equal to b are in the domain of the function, the average rate of change, like slope, is the change in y over the change in x. And we can also say the change in y is f of b minus f of a, and the change of x we can also say is b minus a. where again a is not equal to b. So you actually have a change. That average rate of change is the slope of the secant line. So just as a quick example, if I have a random point like right there, and it touches once, that's called the tangent line. It goes through one time. And if I have that same graph or something similar and it goes through 2 points, then that's going to be the secant line. It goes through 2 times. Okay, so you have lots of different types of problems. You have identify even and odd, determine where it's increasing, decreasing, or constant from the graph, finding the locals and seeing where it's increasing, decreasing, or constant, finding the absolutes, using your calculator to approximate. That's when you can round, and finding your average rate of change and slope of the secant line, and finding the equation of the secant line. Okay, so that's your verbal description or notes. Now, this is how I'm going to start this year. What I am doing, since you're not being issued a textbook, and to make it a little bit easier on you, is I have problems that are printed from your Math Excel, and then at the very back of it, at the very back of it are your answers. So there you can see them right there. The reason I'm doing this is because on ones like this, you don't use parentheses, and on ones like this you do, and you have to have a comma. And your numbers are going to be different anyway, and so that's what I decided to do. So you still may want to end up writing some things in your composition book, but to me this is really important to keep track of. Okay, so one more thing before we get started. So the 2, 3 represents the section, and then the 6 would be the problem. You may have seen that before on other classes, but again, 2, 3 is the section, 7 is the problem, and so forth. Now, the way this is organized is this is all in order and everything, and the first ones are usually vocabulary. Okay, so on the first one, this is a type problem where if you're looking at it on your computer, it has the sentence with a blank right there, but this one is multiple choice, and that little 1 indicates it should be right here. So a function it's either decreasing, constant, or increasing. By the way, these change order. So what we need to look at is if x1 is smaller than x2, so in other words, if we're looking from left to right, if this is down and this is up because of the less than sign, we had this definition a second ago, that was increasing. So if they put greater than, if f of x1 is greater than f of x2, then it'd be decreasing. So that one is a definition. The next one, a blank function is one for which f of negative x is equal to f of x for everything. And so If it's equal to that, then it'd be an even function. So let me explain why. So on that, let's just say you have a little parabola. And let's just say you have the point 2, 4 and the point negative 2, 4. So if x equal 2, then negative x is negative 2. But in both cases, so on both, y is equal to 4. And so that's considered even. So that's specifically why that is. Okay? And then the next one, if it's f of negative x equal negative f of x, that's going to be odd. Now the reason is, okay, and this first one was y equal x squared. If you have one like x cubed, then you'd have 2, 8 here, and negative 2, negative 8 there. And so what you can see is if x is 2, then negative x is negative 2, and the y would change from positive 8 to negative 8. Now, it doesn't just have to be symmetric to the origin, like top right to bottom left. You could have one this way, which would be like y equal negative x cubed, and that's still symmetric to the origin. And you could think rotate 180 or whatever. But it basically means the odd has to be in diagonal quadrants. Okay, number 3, determine if it's true or false. If f is decreasing, I'm just making a random, like, slanting down, then it goes from up to down. Okay, so that's true. That's true. All right. Be sure, if we're in class, feel free to stop me. I can pause the video, talk to everybody, or I could keep it rolling and talk to individuals. Okay, number 4. So this one says it's smaller. So if it's smaller, that's the main thing I'm looking for, and it'd be a maximum. So think of max is less than, min is greater than. That's how you can simplify all that down to. Okay, even functions are symmetric with respect to the y-axis, and you don't have to write it in here because it's right there, but odd would be to the origin. So anyway, there you go. Even is to the y-axis, odd is to the origin. Okay, now on this one, we have our first question that's not really a definition, I guess, but it is a yes-no question. You've got this weird graph, it's probably piecewise, with a cubic function on this side, and then something there, and then something there. So the first thing you're going to want to look at is this, and notice it's an open interval. So that's the only part you care about. And what they usually do is they use one of the numbers, like in this case, negative 8 is right there. And then negative 5 is that number. So here we only care about that part of the graph. We don't even care about that part or that part. So it says, is it strictly increasing? And so that'd be a yes. So this part would be increasing. From here to here is also increasing. From here to here is decreasing, and so is here. Then increasing, then decreasing, then increasing. So anyway, that's how that works. Because they could tell you different intervals. Now, if they said, like, what about from -8 to 1? Well, that'd be no, because it's increasing for 2 spots, but decreasing for 2 spots. So just pay attention to your interval. Okay, on the next one, is it strictly decreasing on the interval 0 to 3? So we just care about here to here. And this is decreasing, but there is increasing. So this is the D, this is the I, and so that's no. So notice on Math Excel, all of a sudden it put yes on top and no on bottom. Over here it had no on top and yes on bottom. So be careful about that. The next one says list the intervals on where it's decreasing. Okay, well, it's only decreasing from here to here. So that's from -1 to 1. So just to be very clear, because of the box, I'm going to put -1, 1. And so again, it's not bracket -1, 1 on what they want. And it's also not just putting -1, 1. In order for it to count it right on Math Excel, you have to use this. And this is where I want to mention increasing and decreasing problems use parentheses, not brackets. So we just want to use parentheses for that. There are other times where we need brackets, like if you're saying, you know, the absolute minimum or whatever, or the domain or range from certain value up. Yeah, I guess that's the best example. So from here up would be the range. This range would be -1, infinity. Parentheses. And then the other way to say it is y greater than or equal to -1. So while I'm mentioning domain and range, that's the range. The domain, we would have said, is -infinity to infinity. Because it's as wide as you want, there's not arrows on this, but you can assume that it continues. It doesn't stop like right there, for example. It just keeps on going. And so that would also be considered all real numbers. Okay, so just wanted to give you a couple of vocab terms from when you had Algebra 2. Okay, the next one, is there a local minimum on x equal -3, which is where that dot is? And it's going to be yes. It's -9. Because if -10 is here, then -9 is there. Okay. Number 10, list the values where there's a local minimum. So if I go back, this graph only had one. This is the only local or absolute minimum. Now this one, on the other hand, has two. This has two local minimums. And so right there and right there. And so that's -5 is listed there, so -6 is on the left. And this is 5, 4, 3, 2. Should be 2. And so on this one, it's not -6 to, on this one, don't use parentheses. It does want your comma between them, but you don't put parentheses. And then, what are they if they exist? Well, the y value is what it wants, and that'd be -4 for both of them. And so what's written in the thing is -4, -4. You could check on Math Excel if it just wants one of them, since it is the same thing. But what I have is that it wanted both, like that. So I'm just going to say check if only one -4. Again, your numbers are going to be different, but that's what I'm curious about. Okay, this is probably good for the first video. We may play the next one the exact same day, but I just want to break it up